Okay, it's already 6 minutes. Still, we have few students who still not appear. Okay, we continue with our lecture for today. Okay, yesterday we stopped at example 1. Okay, we stop at example 1. Today we try to do Berlin design. Okay, yesterday what we did is just until the stage of Berlin load, the analysis for Berlin load. Okay, so example 5.2. Example 5.2, you've been given a truss, a plain truss, okay, with the arrangement of purlin that located on the nodes, and the purlin need to be designed using single angle section with the following data. The information that we have are the spacing between trusses is 5 meter, and also all the loads, the dead load and also the variable load. Okay. Okay. First, we try to gather all the information. What are the information that we can get? Okay. We have dead load, GK. We have two type of dead load here. One is the weight of roof sheet, insulation, and purlin. The load is on slope, which is logic because of course you the roof sheet in up. Okay, the installation of the roof sheet will be related to the angle of the truss. Okay, and then we have say weight of truss, say weight of truss, and then we have imposed load on plan. Okay, so we have two type of GK. Okay, in this case, if we want to design purlin, we just need to consider a load that will be placed on top of purlin. Okay, in this case, we need to consider this load, 0.35 kilonewton per meter squared only, because of course roof sheet will be placed on the on top of the purlin together with insulation and also the safe weight of the purlin itself. Okay, all are considered as 0.35 kilonewton per meter squared. As for safe weight of truss, okay, it is can be seen that the truss will not be supported by purlin. Instead, the main truss support the purlin member. Purlin is the secondary member, okay, and it is placed on top of the top chord or the truss. Eh? To be specific, the top chord. Okay, so if you want to design purlin, just consider all load that placed on top of purlin. Okay, so okay, that is GK on slope. Then QK. Okay, 0.75 per meter squared. This is on plan. Okay. Okay, distance between trusses is 5 meter, means that you should understood by now that we have another truss, yeah, okay, 5 meter away. Satu, dua, sorry, dua, only two. Okay, so okay lah. Okay, so the ST is 5 meter. The SP, if I refer to this diagram, we have SP equal to 6.324 divided by 1, 2, 3. Okay, the distance. Okay, berapa? What is the value of SP? What is the distance of SP? Apa?
2.108.
Okay. 2.108. Okay, meter. Okay, what's next? So we have GK, we have QK. Now we want to design purlin. So for purlin, okay, refer to your notes. To design purlin, what we need? We need the size. So the size, if we follow empirical method, we need to refer to table 29. So table 29, okay, this one is much more, this one is more clear. Okay, we are using angle, right? The example, okay, insists on using angle section, so we need to obey certain apart from the value of Z, which is modulus of elastic, the D, the depth of the section that we want to propose, B is the width or the breadth of the section that we want to propose. We also need to fulfill certain requirement before we use this empirical method. First, we need to ensure that the steel that we want to use or we want to propose as the purlin member, the minimum grade will be S275. So why not we just we fix. This is our decision. Okay, angle section, the angle section that we want to propose, of course, will be in the grade of the steel grade of S275. Okay, we can deal with this later. Okay, next. Okay, we will use on-factor load, okay, and then span to member should not exceed 6.5 center to center from the main support. How can we ensure this? We know that purlin will run from one truss to another truss, and the length is 5 meter. This will be the support for our purlin. This one. This is truss. This truss will be the support to our purlin, which is the span of the truss is 5 meter, and of course the length of the purlin, okay, from support to support will be 5 meter. Okay, do not confuse, okay? Do not confuse with this length. Actually, for purlin, of course, we will have continuous member as long as we can get, okay? Typical length, okay? Typical length for steel section will be 12 meter or 11 meter to 12 meter. Okay, that is the typical. Longer than that, you need to do connection. Okay, then you can have continuous member. Okay, since the span is 5 meter, okay, for building length, I don't think you need 5 meter only. Building length could be up to apa? It could be 15 meter, let's say 15 meter. So your purlin will run until 15 meter. Then you know that after 12 meter, because that is the maximum length, okay, of steel, Okay, then you need to do some, okay, you need to do a connection. Okay, okay. In real practice, okay, in real practice, this will be continuous member. Okay, so do not confuse when I said, okay, the span is 5 meter. I mean the span between support to support of the purlin. Okay, the purlin can go up to 50 meter. Okay, just that we need to design just one span. Okay, so 5 meter, which is similar to the distance of truss, because the truss will be support the purlin. Okay. Okay. What else? Okay. Then what is the other requirement? So we fulfill this two. Yeah. Ours is 5 meter. This one, maximum 6.5. Where the member generally spend only one bay, each member should be connected. Okay, this one you can decide later. Make sure that you provide at least two fastener, two bolts, okay, at each end. Where members are generally continuous over two or more bay with staggered joint in adjacent lines of member, at least, okay, one end of any, okay, this one you will decide later. This will be your detailing after you finish design it. Okay, for specific rule, it said that the loading on the purlin should be substantial, uniformly distributed. Okay, imagine your purlin is supporting roof covering. Do you think that roof covering is a point load in the form of point load? No, it is UDL load. Okay, it will transfer as a UDL load. Okay, not greater than 10% of the total roof load or member should be due to the other type of load. We do not have the other type of load. We only have roof covering and other things like apa apa yang untuk haba tu, insulation. Okay, insulation. That's all. Insulation is much more lighter. Okay, I don't think we can exceed 10%. Okay, impulse load should be determined, okay, but should not taken as less than 0.75. In this example, the QK is 0.75, which is similar. Then we can use this approach. I think we have another. Okay, this one, slope. The slope of the roof should not exceed 30. Okay, in this case, we need to check. We need to check what is the slope here, alpha. What is the alpha here? Okay, easy peasy. We have 12 meter span. So half is 6. This one is 2 meter. So alpha, hypotenuse, sebelahan, tentangan. Okay, sin alpha 2/6. Sorry. Salah. Tak nak sin. Tangent. Tangent. Tangent alpha. Okay. So alpha berapa? What is the degree? What is the slope degree? Abdi Razak, can you calculate for me?
Yes, doctor.
Abdi Razak, okay. Can you calculate it for me, please? Abdi Razak? What
Yes,
is the
teacher.
answer? Huh?
Uh, teacher, six.
Huh?
Six. Number six.
What?
Number six.
Number 6?
Yeah.
Oh, no, I do not understand. What's that? Can you, maybe you can type here in the chat box?
Okay.
Okay. Six. How come it can be 6? How come it can be 6? 6 degree?
Yes.
Oh, this is simple calculation. How come you do not know? Tangent alpha is equal to 2 divided by 6. What is alpha? Do you have your calculator with you? Abdiraza, it's not 6. Logically, it's not 6. You can see. You can see directly what is the answer here. 0.33? Oh, dear. What's tangent? Tangent.
18.43.
What? How come you get 0.33? Abdiraza, how can you get 6?
Uh,
This is simple mathematics. All engineering students should know mathematics. Do I need to teach like a... Okay, I do not want to show to you how to calculate this thing, but the answer is 18.4 degree. So for 18.4, which is less than 30, so means that we can use the empirical method. Okay? So in order to use this empirical method, the final result that we want, because we deal with design, of course we need to know what is the suitable size. We have decided that we want to use angle section. So referring to table 29, we will refer to angle section, this one, where the Z, okay, the limit, the minimum value, I told you yesterday, this one is indicate the minimum value that you need to fulfill. So the Z is equal to WP times L divided by 1,800. Well, for the B, L over 45, and B ke D? No, D. This one is D. B is equal to L over 60. WP is said the total unfactored load on one span of the purlin. Yes, we deal with only one span. How do we know? Remember, we take the span as 5 meter. Kan? We know we take L is 5 meter. This is just for one span. Logically, we will not have a building with length of 5 meter only. Building, I said building, not small pondok not the small store or whatever. Okay, so it's not logic for us to have like just a 5 meter. So we will have few trusses here, and still your purlin will run until the end of the building. So it's kind of it is like a will be like a 20 meter long, okay, but since it is actually a continuous member, okay. So for this case, we need to consider only one span. Okay, so it said WP is unfactor load, means that 1.0 GK plus 1.0 QK. Remember, I'll stress again, this is the typical load combination. In real case, you need to decide which load combination is the most severe case. Okay, is most the severe case. Okay, you have like a form, mana? Load combination. This one. Okay, if there is a wind pressure that need to be considered, 1.0 GK, 1.0 QK, 1.0 WK. But for the purpose of example, I just consider the typical load combination. Okay, 1.0 GK plus 1.0 QK. So we know that the GK for this example, GK, berapa GK? 0.35, right? Kilonewton per meter squared plus 0.75 kilonewton per meter squared. So the WP will be, calculate for me, berapa? What is 1 point?
1.21.
1.21. 1.21, okay. 1.21 in unit kilonewton per meter squared. Okay, now kilonewton should be in, WP should be in the unit of kilonewton, should be in kilonewton. Okay, so you need to convert. So how can we convert it? Okay, so we need to refer to plan view. You can sketch the plan view because you have all the details. Let's say this is truss 1, then we truss 2, truss 3. Okay, what we need, just 3 trusses. We need 3 trusses because we need to consider intermediate purlin. Okay, because intermediate purlin is we want to consider the severe case. Okay, let's say this is the apex. Okay, so the plan view, the elevation view will look like this. This is the apex. Okay, and then we have purlin. Okay, purlin. So we have purlin here. Okay, we have purlin here. Okay, purlin, this one, purlin. Okay, so the intermediate purlin will create the most severe load case, load area. Okay, so the load area, like I said, half will be supported by this purlin. Another half, okay, also will be supported by this purlin. This one will take another half of this length and half of this width and this length. Okay. So we just consider 1 point only. Okay. So what is the area? Okay, this one half. Tadi berapa? 2.018 kan? Kan betul? 2.018.
Betul.
Okay, so this is 5 meter. 5 meter, so 2.5. 2.5, okay. Okay, we sum up this value. Again, we get 5 meter. Yeah, 5 meter. This will be the ST. This is the SP. Similar to the SP. But the understanding, it is half. And then another half. That is the understanding. Okay. Okay, so this is the area. Then WP should be multiplied by area. Area in this case is 5. WP is 2.21 kilonewton per meter squared. Multiply by area. Area in this case is 2.018 times 5 meter.
Doktor. Sorry.
Ya.
Baru tengok balik, dia punya SP tu 2.108. Bukan 018.
2.108. Okay, 2.1. Okay, 2.108. Okay, 2.108. Okay, calculate for me, please. Okay, do not rely on the answer in this slide. There must be some mistake sometimes. Okay, we need to always double check. Okay, dead load. This one, DL and IL represent dead load and imposed load. Dead load is permanent load. Okay, the new term is permanent load. Imposed load is the variable load. Okay, what is the answer? WP in kilonewton?
1.7.
Sorry, is that Ali?
1.7.
1? Sorry, I can't.
12.75 Doktor.
12.75. Yeah.
Yeah.
12.75. Okay, now we can substitute this value into this equation. We have 12.75 times L. L, what is L? L is the span of the purlin that we consider. Only one span, so only one span, okay? So one span, so 5 meter. But in unit millimeter, as you can refer to the table.
Doktor,
Yeah.
sorry interrupt. Yang WP tu, it should be 1.1 I think, not 1.2.
WP
1.1.
1.1. Oh, bukan 1.2 eh? Okay, so calculate balik.
Doktor,
Ya.
tapi kat soalan yang dead load tu on slope dengan imposed load on plan. Jadi boleh ke tambah macam tu je?
Oh, no. We cannot tambah. We cannot add. We need to convert first. Okay. We need to convert it first. Okay, so we need to convert. Sorry, we need to convert. Ini kita miss We need to convert. We cannot directly add. Okay, GK berapa tadi? GK is 0.75 0.75 kilonewton meter squared, but this one is
GK 0.35.
sorry, QK is 0.75. Okay, this is on slope. Okay, okay, this is on slope. But we need to convert to on plan kan? We need to
Tu,
convert to
wait,
on.
yang tu dah on plan, yang GK tu yang on slope.
Oh, saya salah. GK 0.35. Betul? GK 0.35. GK 0.35. This one is on plan. On slope. On slope. Okay, this one on slope. Okay, ni on plan. UK on plan. So we need to convert to on slope. Kejap ya. Apa nak convert on slope ya? Kenapa tak on plan? Okay, kejap eh. Okay. Okay. We continue. Okay, GK. In order to design purlin, all should be on slope. Okay, all load should be on slope. So we need to convert this one, QK to be on plane. So QK is on slope, on slope. Originally it is on plane, so convert to on slope is equal to 0.75 multiplied by 6 divided by 6.324. Berapa? 0.71. Sama ke? 0.71 kilonewton per meter square. This one slope. Betul tak? Agree?
Betul Doktor.
Betul.
0.71. Okay, thank you Akmal. Okay, now then we can add. Okay, so 0.75. Okay. And add another 0.1. So what is the final answer for WP? WP 1.06. Betul? 6,
Betul Doktor.
7, 10. Okay, so 1.06 here. 1.06 multiplied by area. Area is 2.108 times 5. So what is the final answer here? WP? WP?
$11.19.
11.19. 19. Is it okay, we round up the number 11.2. Betul? Okay, 11.2 kilonewton. So now it is already in kilonewton. So we substitute this value times 5,000. Okay, why 5,000? It is because referring to this table L millimeter. Okay, in millimeter. So that's why this one 5,000. Then divide by 1,800. What is the answer? Okay, berapa? 11.2 times 5,000 divided by 1,800. Apa? Then the answer Z will be in centimeter cube. This table will be directly in centimeter cube. Berapa? 11.2.
31.1.
31. 31.1. 31.1. Okay. That is the minimum value for modulus of elastic. Modulus of elastic. Z is modulus for elastic. Okay. D, L divided by 45. L 5,000 divided by 45. This one is 11.11 in unit millimeter. In unit, this one millimeter. B also in millimeter. Okay, for B, L is 5,000 divided by 60. What is the purpose of set rod? Okay, we put set rod because we want to reduce the deflection, okay, of that member. Because very small, but it has to it's quite long. Maybe its own self weight or due to the self weight attached to it. Okay. Normally there's no load. There's no load that we put to the set rod. Okay. Afraid that the set rod will bend under its own self weight. Okay. So that set rod, of course, there's no load on set rod except that its own self weight. We afraid that the purlin will bend because purlin normally varies. It should be smaller. It should span until 5 meter long. Okay. So if we use set rod here, okay, L is the center to center of the main vertical support. In this case, the main vertical will be the trusses. But where properly supported set rod are provided, may be taken as the set rod spacing for the determination of B only. Only B will involve. And then it said set rod say we use only one set rod at spacing will be 2.5. Right. You just divide by 2. Okay, you just divide by 2. So this one divide by 2. Okay. Okay, berapa? 2. So this will be 41.67 m. Okay. Okay. Until this stage, is there any question that you want to ask? Can you follow?
Doktor, boleh tak doktor terangkan balik yang 5,000 bagi 2? Sebab tadi line doktor sangkut-sangkut.
Oh, sangkut eh?
Oh.
Okay. I repeat again. If you want to use set rod, normally we put set rod, okay, at the intermediate, at the mid length, okay, at the mid length of this purlin. Okay, our purlin is 5 meter length, okay, between support to support. So you need to divide by 2. But that one is only applicable for calculating B only, not involve D. Just B only as indicate in this table. Table 29. Boleh faham? Clear tak? Boleh?
Clear, doktor.
Boleh Tadi clear tak? Ada sangkut-sangkut ke? Kalau guna set rod, bahagi 2. Actually ikut berapa spacing set rod. Tapi selalu kita pakai 1 je. That's why bagi dengan 2. Okay. The L should be according to the spacing of set rod if you provide the set rod or if the set rod are provided. Kalau awak gunalah, kalau you sediakanlah. Okay. But again, the set rod distance or we only consider when you want to calculate B, the breadth, the width. Okay, only B. Okay, so in this case, we can say that, okay, according to table 29, the minimum value, okay, that your purlin has to fulfill, the modulus elastic should be bigger or equal to 31.1, 31.1 or 0.6 centimeter cube. The depth of your purlin should be bigger or equal to 111.1 millimeter. B is equal to 41.67 millimeter. This is all minimum value that you need to fulfill. Okay, now it is time for you to choose the size. Okay, so based on the blue book, okay, based on your blue book, look for angle section. Okay, angle. Okay, you can choose equal angle or unequal angle. It is up to you, but I think unequal angle is much more suitable. Yeah. Mana? Oh, banyak sangat. This one is unequal angle. Sorry, tak nak. I do not want that table. I want dimension and properties table. This one. Okay, this one using double angle back to back. No, I want to use single angle. Okay, let's see. Single angle. Okay, unequal single angle. Okay, so now, okay, dimension and properties. Okay, dimension. This is h, right? Small h. D is based on old code. Okay, D is equivalent or similar to H in the new code. Right? This one is depth. Last time we used depth. Now it is height. B, capital B for breadth. Also B, but small b for breadth or width. Okay. So based on table, sorry, not table, apa? Based on blue book, the minimum of modulus. Where is elastic modulus? This one. Okay, continue. Continue. Okay. Elastic modulus should be not less than 31.1 because this minimum not less. 31.1. So modulus elastic. I have two modulus elastic, Y and Z. So which one should I refer to? Which one should I refer to? Is it okay? This is our rafter here. This is our rafter. If arrange my purlin okay. I don't
Sorry, doktor boleh
I don't
ulang.
think you want to arrange
Doktor
your purlin
sangkut.
like this. Sangkut Okay. I have, based on the blue book, okay, elastic modulus, we have Y, we have Z. Okay, so which one that you want to use? I said that you need to choose the bending axis. Which one will be this? Based on the arrangement, based on your purling arrangement. Arrange purling logically, how to attach this to the top chord? We need an angle, okay, and then we will have connection. Then your roofing, okay, then your roofing will be attached and connect to one of these leg. Okay, maybe we try to see real picture. Okay. Angle purlin on rafter lah. We try. Okay. See, this one is using Z section. For no, we okay. I don't think hot roll ada. Hot roll, does hot roll has Z section? This one normally for cold form lah. Cold form. Okay, it's okay. We try to look for another picture. What about this? This is Z. Kita nak angle. 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 Ni, this one. Angle. Nampak? Okay. Boleh nampak Okay, this is angle. This is the purlin. This is the purlin. We need another element so that the purlin can be in this position. And then we will have connection here, and then your roofing, okay, will be on top of the purlin, and then we will have another connection at this leg, dekat kaki dia, the leg of this angle. Okay. So, if the arrangement of your purling, okay, this is the arrangement of your purling. Okay, then we need another small element attached, and then attach your roofing. Okay. Can you imagine where is the buckling axis? This is load on top here. On slope kan? On slope. So, it will bend about this axis. Nampak ni? This axis. And what is the axis? Apa axis ni? Y or Z? Okay, then refer to your blue book. Imagine this one, rotate, then you rotate, Y axis is still here. This is Y, yeah, Y axis, Y perpendicular to the long leg, Z parallel to the long leg. Okay, well, okay, this one is Z. So, due to this loading, of course, the bending will be about the Y-axis. So, in this case, you need to refer to W elastic or Y-axis. Okay? Y-axis. Okay, this is elastic modulus. So, for Y-axis. Okay? I know that the minimum value that I can go is 31.1. So I cannot choose 29. So the closest one will be 36.5. Okay, 36.5 for size 1 to 5 times 71. 1 to 5 times 75 times 10 thickness, 10 mm thickness. This one, 10 mm thickness. Okay. With WEL is equal to 36.5 centimeter cube, which is slightly bigger than 3106 centimeter cube. Okay, pass for modulus. But for H, okay, H means that we have 125 times 75. It means that H times B. So the H value represented by 125. 75 represent the B. Okay, now H, the minimum we need is 111, but here is 125. This one is less than 125 mm. Let's say this is our initial proposed size, okay, for an angle. So looks like that H is passed to. B, okay, the minimum we need is 41. 41 is less than 75, okay, also pass. This one also pass. So I can suggest to use angle with this size for the purlin. Okay. Boleh faham? Boleh faham?
Doktor,
Yes, Doktor.
tadi tu macam mana nak bila kita dah guna unequal ataupun equal angles Kenapa guna unequal?
Depends. Let's say if you want to use equal angle, okay, equal angle. Equal angle, okay. Modulus, elastic modulus, Y and Z is similar. Then, okay, we know that the minimum is 31. Okay, looks like this one is the closest one. The closest value, 35. So you need to use 100 times 100. But your H, the minimum is 111, but you provide 100. So, tak pass. You cannot use this. You have to go a little bit bigger. So 120 times 120, and the minimum thickness you can go is 10. 10 because 10, the modulus is the modulus elastic for 10 mm thickness is 36, which is slightly bigger than 31. Yeah, the minimum. Okay, the minimum value that you just calculated, 36. Okay, so 120, the H is 120, the minimum is 111. Okay, pass. B, you only need 41, but you provide 120. Okay, still okay. Okay, I do want to talk about the cost. I do not want to compare 125 times 75. What is in terms of price? Which one is more expensive? 120 times 120 or 125 times 75? I do not want to go to deeper than that. Okay, I do not want to go deeper in terms of cost. Okay, so to me, I prefer to use unequal because I do not know. I just feel that I provide slightly just enough lah, more than enough, but not excess. Tak berlebihan. Okay. Okay, it depends. It depends. You still can use this size. It still pass. Okay. Okay. Soalan lain? Is there any other question? Any other question?
So far okay, Doktor.
Okay, next. Now, we're done with Perlin design. Now we want to analyze what is the load, okay, to be considered if we want to determine the internal forces in the truss member. This one. We want to know what is the internal forces in this truss member. Just now we already finished with designing the purlin. Okay, settle. Okay, so in order to determine the this load, okay, you need this load, right? Yeah, you need this load to come up with the analysis, the joint analysis, the cut section analysis, the diagram analysis, or whatever method that you want to use. Okay, doesn't matter. Okay, what is the P here? Okay, now GK, we have two types of GK. We have 0.35 kilonewton per meter squared. We have QK 0.75 kilonewton per meter squared. This one on plan, this one on slope. And then we have another load, also GK, but this is the weight of thrust. The weight of thrust, berapa? The weight of thrust 0.2 kilonewton meter squared. It said on slope. No. The logic, it is not on slope because weight is gravity load. Gravity. Okay. This one, yep, logically it should be on slope. The load should be on slope because this is the way you arrange your roof on slope. This one is not related to it's not related to this. Not related. This one should be on plan. Okay, we change it. Okay, we change our question. Okay, this one is gravity load. Yeah, on plan. Okay, on plan. It should be on plan. It's not related to the slope. Okay. Okay, now in order to determine this value, the P here, we need to consider loading on plan only. Means that this one you need to convert to plan. So 0.35, okay, multiply by, okay, on slope, on plan, convert to on plan. So hypotenuse sebelahan tentangan. So tangent, cos, sin, which one? This is alpha. Cos, cos alpha on slope divided by on plan. Okay, cos alpha. Alpha is 18.4. Okay. On slope 0.35. Okay, so on plan is equal to on slope divided by cos alpha. Okay, so on plan, on slope is 0.35. Divided by cos 18.4. Okay, berapa? Berapa?
Zero point 3688. 0.3688. Yes, madam. Yes, Alexa.
Okay. Okay, so on plan, the value of GK 0.3, let's say 0.37, okay? Round up. Kilonewton per meter squared. Okay, now we know that the design load, we need to consider design load. Design load, okay, I just use typical load combination, 1.35 GK plus 1.5 QK. Okay, we need to use factor because this is no more purlin design. Okay, so 1.35 times GK, GK is the okay, 0.37. We need to sum up this value times, okay, plus 1.5 times 0.75. So P here, okay, berapa? In kilonewton meter squared, but P I need in the final answer should be in kilonewton. Okay, calculate. What is the value? I don't think this one is correct. The one that in this slide is correct. Okay, come on guys, berapa? Okay, berapa?
1.89.
1.89 in kilonewton meter squared.
Yes.
Okay, in kilonewton?
20.03 kilonewton.
0.3 kilonewton. Okay, good. Let me check. Okay. Okay. Now you have the value. Okay. Just consider the point load as 20. 20 kilonewton. Okay. 20 kilonewton. Then 20. This one should be 10. Kan? This one should be 10. Okay, based on this value, now you can proceed with join method. Join method. With join method or the diagram method in order for you to determine the internal forces. I will not teach you that. You already learned that in your previous years, previous semester. Okay. Okay, that's all. That's how you analyze. And then you need to come up with the answer for all member, the internal forces for all member. Or you can use software. No more hand calculation, but you need that knowledge. You need that knowledge first to manually calculate the value. Then you can proceed with using software. Okay? Okay. Ada nak tanya? Is there any question? Is there any question?
No.
Okay, faham Okay. Ni lagi tak? Okay. Okay, I want to, okay, this one. This is about the internal forces. Okay. Internal forces, concentrate on primary force. Primary force is the internal forces in the truss member in the form of axial load, axial force, daya paksi. Okay, in the form of axial load. That is primary force. Okay, the primary forces in all member are calculated by applying load at the nodes, like this one. Okay, not like this one. Okay, and assuming the truss is pin jointed, we assume all the truss, okay, using pin jointed. Okay, and statically determine it. Okay, several manual analysis is available. This one, joint resolution, using diagram or method of section or cut section. Okay, what you can get from this method are the primary force in the form of axial force dalam bentuk daya paksi. And the axial force will represent tension or compressive force. Okay, the member can be experiencing tensile or compressive. Okay, then okay, this one is about secondary stresses. Okay, in many cases, it's not necessary to consider secondary stresses. However, these secondary stresses is significant if you design heavy trusses, especially in the industrial building and also bridges. But for domestic building, it's not necessary. Okay, sometimes because the secondary stresses is small. Okay, but it is significant. Okay, to be considered for industrial building and bridges. Okay, do not avoid, do not ignore. Okay. Okay, secondary stresses are caused by, first, if you have load in between node, like what I have explained yesterday. If you have load in between node, means that not only you need to consider axial load that coming from the primary force, okay, that coming from this method, joint resolution diagram or method of section, but you need to consider also secondary stresses because of the bending. Okay, load in between node will create bending. Okay? Okay. The other causes, because of you have eccentricity at connection. And last, there's a moment because you use rigid joint. Yeah, there's a moment because of using rigid joint, and there's a deflection that occur in the truss, on the truss. Okay, eccentric at connection. Okay, the eccentricity actually exists when you, because of the arrangement of the members at the connection, at the point of the connection. Okay, the eccentricity exists when all the centroidal axis of the member at the joint location doesn't meet at the same point. That's why you will have eccentricity. Eccentricity, okay, you have load and then you have eccentricity. Moment will transfer to the node, and bukan node, sorry. Load will be transferred to the centroid. We talk about centroid of connection, not centroid of your member. Okay, do not get confused. It's not centroid of the member. Okay, macam ni. I think I'm using the picture from internet. Okay, eccentricity. This one. Eccentricity will create copy image. Letak mana words? Yeah. Okay, let's see another picture. Okay, ni nampak tapi okay, boleh lah ni. Okay, see? This is the member axis. Another member axis. This is also member axis. See? It meet at the same point. So there's no moment. Okay. Saya conteng Macam mana moment tu ada? Okay. Remember that you analyze using joint resolution or the other method. What you will have? You can get axial force. It could be tension. This one, compression Compression kan? Ni member, this is member. Tension will be like this kan? Tension will be like this, keluar. Okay? So you can have like this or like this. Okay? If you have eccentricity, let's say you have gap here, like this, okay, this one. This is E, eccentricity. So moment is equal to load N times E. Okay, so this member will create moment. We call it as a nominal moment. Okay, ini, there's also moment here. Okay, that's how you can get moment. That's how you can get eccentricity in this case. Okay, so trusses should be detailed so that either the centroidal axis of the member or the bolt gauge line meet at a point at the node. Otherwise, member and connection should be designed to resist, to resist moment due to eccentricity. And then this moment Here we have moment here in this case, and this moment should be divided among the member, among these three member at this point of connection. Okay, how can we divide? It will be according to the proportion of the stiffness. Ikut kadar of the stiffness of the member, according to the proportion of the member stiffness. Kena ikut kadar, perkadaran. Okay. Okay. This moment should be divided between member meeting at point in proportion to their rational stiffnesses. Okay, stress due to small eccentricity are often neglected. That's why I said for just a small trusses, okay, sometimes, okay, because of this assembly, I don't think you can meet at this centroid of connection. Okay, I don't think that you can meet exactly at the center of the connection. So maybe you have a small eccentricity that will create a nominal moment. Okay, that stresses you can ignore. Okay, just small moment. Yeah. Okay. The solution often occur to the rafter of the trusses where, okay, another case, okay, another case is where you have purlin that not positioned or not located at the nodes. Then you can get secondary stresses. Okay, eccentricity creates secondary stresses. Load at node also create secondary stresses. But secondary stresses in this case, okay, in this case, I mean where the purlin not located at nodes, okay, will only affect the rafter member. Okay, you have a lot of truss member here. Okay, but when we deal with purlin that not located at nodes, it will only affect the rafter, the top chord. This purlin will create bending, but it just involves the top chord. So for top chord, you will have N, I mean the axial force, this one will be in tension or compression. Tension or compression. Tension or compression. Tension or compression. Under typical load case, top chord will be in compression. Compression. Under normal load condition, the bottom chord will be in tension. Remember I said because of the load here, this one will expand, this one will compress. It's move downward, it will compress. This one will be elongate, it will be in tension. Remember the terminology last time, yesterday? Okay, so to design the top chord, okay, apart from compression force, apart from the compression force, you have axial, apart from the bending, this one create bending, you have compression force. C lah, saya letak. I put it as C, compression force. The axial force is in compression. Axial force can be tension or compression. Okay, but for top chord, they will experience compression. Okay, just involve top chord. Tension, bottom chord, you can design with on the single force, which is axial force in the form of tension. This one, wet member, it's like a strut kan, macam tiang kan. So it will be in compression. This one, compression. Compression. Remember, you have load on top. Compression. Kena tekan kan, logic lah. Compression. But for incline member, it can be both. Okay, maybe this member in compression, this one in tension. It can be in two case. Okay. Okay. So how can we analyze? How can we perform the analysis? Okay. In most cases, it's not necessary to consider secondary stresses, okay, in the design of truss and lattice girder. However, for heavy trusses, bridge and industrial building, you need to consider. You ought, these secondary stresses ought to be calculated and consider. How can you calculate? Of course, maybe you want to do moment distribution, okay, manually or using computer software. Okay. Okay. Like I said, top chord in this case where load applied in between nodes. Okay, the top chord, only the top chord will be designed to support axial force and bending. Okay. There's a procedure to analyze this case. Okay. Okay. You can get axial force, okay, based on that three method: section, cut section, joint resolution, or diagram. But for bending, you need to calculate. But we have alternative method where you can calculate the bending moment based on this conservative approach. Just take WL power of 2 divided by 6. This one is allowed in old code BS 5950. What is W? W is the total load per unit length. Means that kilonewton per meter per unit length. Multiplied by span. L power of 2. Okay, L is meter. Meter power of 2, so meter squared. Kilonewton per unit length for W. Okay, W, L power of 2 divided by 6. W here is in kilonewton per meter length. L, meter. So power of 2, then power of 2. So kilonewton per meter times meter, power of 2. You will have kilonewton meter. This is moment, right? Unit for moment. Okay, that is how you calculate, you consider this bending. So this is moment. This one based on that three method: diagram, join, method of join, cut section. Okay. Okay, we are quite detailed about this one. Okay, but okay. This is, the diagram. Okay, I hope this can help you to understand more how to analyze that case. Okay, the first thing that you need to consider, I know that the actual load, actual condition, the actual condition of the truss is having purlin in between node. This is the real, the initial condition, the first condition, or the real condition. The real situation, you have the truss with purlin in between nodes. There's a purlin on node 2 and then purlin between node. Nampak tak, kecil je. Then the first analysis that you need to do is to determine axial force or internal force in the truss member. Okay, so in doing that, assume that all loads are located at nodes. Just assume. And then you carry out the section, the joint resolution method, or whatever method that you prefer. Okay, then you can get tension or compression force, or you can get internal forces in the truss member. The next step, consider only the top chord with actual condition where the loads are at knots, at in between knot here, represent between knot, and then you have another 0.3 at knot, in between knot, at knot, in between knot, and then this is the peak. Okay, I think better I highlight this one so that you can okay, this one. Okay, this is the first step. Ignore purlin between knot. Okay, ignore. Okay, then you can have this situation. Then you can proceed with analysis of your choices. You have 1, 2, 3 options. Okay, and then the result will be in the form of axial force. Can be tension, can be compression. These two type of load known as internal forces, daya dalam anggota kekuda. Internal forces. Tulis bahasa Melayu pula. Internal forces. Okay, the next step, just consider top chord or rafter. Just consider the top chord with the actual load condition, but just half only, half of this rafter, because this is similar, right? Just perform at half of it. Okay. Okay, with the actual load condition. Okay, where the first purlin at knot. This is support, right? Support. Because purlin is supported by this one. This is support. Support the purlin at knot. At knot is assumed as a support. Okay. So first purlin, second purlin here, the second one, the third one. See? This one on knot, this one between knots. Okay. Number 5, number 6, 5, 6. Okay, and then that's all. Half. When you consider half, of course, you need to consider that as a fixed joint. Bila dia symmetry, bila awak nak consider separuh, memang you kena anggap fixed joint. Okay, from this assume as a beam. I said that rafter as a beam, Assume as a beam, but this one is continuous beam. Continuous beam. How do you analyze continuous beam? I bet you already know how to analyze. Kan? Macam mana? Macam ni. This one. Takkan macam ni kot. Continuous macam ni lah kan? Kan? Yeah? I bet you already analyze. But to simplify our analysis, you can use conservative method where the moment here, all the moment here, you can use WL power of 6 divided by power of 2 divided by 6. That's all. Easy. W in kilonewton per meter. L power of 2 means the span, and then divided by 6, or just assume WL per 6. W is in kilonewton meter, the capital W, the unit is in kilonewton. It is the same, just the unit is different. Okay, boleh faham ke tak? Boleh faham ke tak? We have one example. Just a simple example to show you how to analyze this situation. Okay, later on, I think maybe next week. Okay, okay, this is a diagram just to simplify this explanation. Okay, first, this is the actual condition. The first step, assume all loads are on nodes. Primary analysis, all load are on node. Second step, this is secondary analysis. Just consider the top chord as the continuous beam, but using the actual condition. This is support. Support is represent the node. Support represent the node. Okay, and then you can do the continuous beam analysis. You already learned during the analysis subject. You already learned. Or you can go for simplified method or conservative method. Just assume the maximum moment as W, L power of 2 divided by 6. Small w, okay? Or capital W times L divided by 6. And then I said this one assume as fixed. Why? Yep, you need to assume as a fixed because you do not consider the whole length of the rafter. Okay? When you cut something, assume that as a fixed connection. Okay? Okay, that's all. I do not take your attendance yet, but I will. Okay, bear with me. Okay. And that's on 6 April 23. Okay, what I want to ask you. Okay, assess your author and answer this question. Okay, I will consider this as your attendance. Okay. Okay, to those who already answer, okay, thank you. And then I'll see you next week. We might not have class on Wednesday because I need to go to hospital. So can we have replacement class during weekend? Are you okay with that? I need your, if you agree, then we can do. If you are not agree, I cannot do. Okay?
Kalau weekday malam,
I can do, during the evening. Maybe during the weekday, Sunday evening until, Sunday or Monday evening. On Tuesday, I have to commute to KL. Okay, so I cannot do classes during the evening time. Okay?
Doktor, Monday lah.
Monday. Okay. Monday. Is it okay with you? Or you need to vote? Okay. Saya vote kita buat vote
Buat vote doktor.
Okay, later on in our WhatsApp group. Okay, bye. Bye for now. See you again.
Thank you, Doktor.
Ya.
Thank you,
Doktor.
Dah jawab
Doktor,
Ya.
dekat SMAP kan,
Doktor.
dekat attendance, doktor salah tarikh 30 hari bulan 4.
Oh, okay. Nanti tukar.
Thank you,
Tukar
doktor.
bertiga. Okay, macam nak tengok ni result full detail. Full detail. Dah ke? Oh, okay. Mana yang lain ni? Syusmita, Syafika, Liana, Abdi Majid, you were there. Abdi Majid ke Abdi Razak? The one who answer the one who answer question during the class.
Doktor,
Doktor saya dah answer.
Dah Okay,
I
maybe.
can't answer. I don't know what's problem.
Why you can't answer? Why? I didn't put any limitation. You need to try again. You need to refresh your author. If it is idle for quite some time, it will automatically sign out. Okay?
Doktor, boleh tak nak slide yang selebihnya tadi?
Nanti sebab slide tu nampak tak cantik lagi nampaknya. Ternaik atas, ternaik nampak Okay, nanti saya bagi. Okay. Saya akan bagi beberapa stage lah. Macam hari ni kita habis kat sini. Yang ni saya dah elok dah. Saya dah buat cantik dah. Tadi saya dah betulkan. Saya dah memang plan saya nak ajar sampai sini. Okay, dan ni dah elok. Okay, saya akan post sampai setakat ini. Yang lain saya tak nak bagi lagi. And then later on, bila kita dah masuk ni, topik yang ni, saya bagi lagi sekali. So, awak akan ada beberapa kali ni lah amendment. Nanti saya bagi. Saya belum orang kata create lagi file yang baru. Okay. Okay, siapa yang dah buat ni? Okay, bye. Siapa yang belum, saya tunggu lagi.
Thank you, Doktor.
Okay,
Thank you,
you're
Doktor.
welcome.
Thank you, Doktor.
To those who has problem,
Thank
please.
you, Doktor.
To those who have problem, please message me now. Then I know that you are currently in my class.
Doktor,
Siapa?
nak tanya.
Okay.
Doktor, modul tu kan, saya sebenarnya dah terbayar asing.
Terbayar asing maksudnya tu?
Sebab kan sepatutnya kan kalau dalam form tu dia ada kata isi dengan example, book example
Isi.
sekali kan. Tapi saya tak baca yang tu, saya beli dua-dua tapi saya bayar asing. Kiranya saya isi 2 kali form.
Okay, tak apa. 2 kali form tu, bila dah masuk Google Form tu, dia dah keluar. Awak nak modul, awak nak apa. Awak isi 2 kali form. Baguslah. Betul lah tindakan awak tu. Saya dah kira berdasarkan pie chart dia tu, berapa orang nak isi, berapa orang nak Eurocode. Saya dah kira. Kalau you isi 2 form tu, betul. Betul cara tu. So jangan risaulah. Memang dia dah termasuk dalam statistik tu.
Okay, Doktor. Terima kasih,
Okay.
Doktor.
Sama.
Doktor dah keluarkan nama saya